Hello everyone, and welcome to my mini-series about the JetCar project. I started it sometimes back during the pandemic. However, due to moving and following house remodeling, I had little time and space to continue until recently. Finally, I was able to pick my JetCar project up again and finish it. When I began working on the videos, I realized there was too much content to cover. As a result, I divided it into different topics and arranged them in chronological order. Here's a list of all the videos, and I will provide links in the bottom so you can easily access the ones you're interested in. For example, if you want to see the final result immediately, you can go directly to the last video. What is the project about, and why is it named JetCar? It all started with the Jetson Nano board from NVIDIA and the JetBot. I wanted to get into machine learning, and it looked like a fun project to get started. Here's NVIDIA's website, and the overlaid video demonstrates the JetBot and the JetRacer. Both use a simple model that produces the steering value as output. You record several pictures with a camera and mark the steering direction on each of them. Through training, the model learns to apply the correct steering value to keep the vehicle within the street markings. So I built my own JetBot from plywood and balsa, which I had laying around from my RC planes. Instead of the caster of the original JetBot, I used an RC plane tail dragger wheel. Then I marked the street with tape on the garage floor and trained on it. You can see the result here as the JetBot follows the center even through the right angle turns. In the Jupyter notebook on the PC, you can view the live stream from the camera and see the steering direction overlaid by the model. I enjoyed watching it for a while and attempted some additional experiments. I introduced a T-intersection and included more model outputs to enable the JetBot to turn left or right. However, these modifications did not work well. After trying various approaches for some time, I eventually gave up and concluded that this system seems to have its limitations. Road following is around for a very long time. There are examples with only 2 transistors, all analog. With computers and ML, you should be able to do much more. What about the directions? How to tell apart the driving directions from the opposite direction? What about the multi-lane streets? What about intersections? How about turning left or right? What about stop signs? And many more questions. So I had to come up with a project plan. Number 1, get into CNN architecture and tools like PyTorch, image segmentation, Catalyst. Number 2, get a more compact vehicle. Plan A would be find a small RC car to rework. Plan B? I would have to design my own car and finally get a 3D printer. And number 3, create a street map. Again, there's a plan A, check Lego street maps and similar. Or B, make it yourself. Regarding point number 2, I could not find an RC car of the correct size and capable of making tight turns. So you may have guessed it, I finally found a reason to buy me a 3D printer, and I got this Ender 3 Pro. Later I bought this tent, since my garage is getting cold and humid in the winter rain season. The next step was finding a 3D design software. After testing FreeCAD for a bit, I discovered Fusion 360 and decided to stick with that. It's free for personal use. I'm not a mechanical engineer, but I found it intuitive and easy to use. I began by focusing on the largest components, the battery pack with connectors and the Jetson Nano board. These 2 components provided the basic outline for the car. I also found wheels and motors and created models for them. As mentioned before, I wanted to achieve a small steering radius for tight turns. It was crucial to ensure that the front wheels had enough space to move, and the steering geometry was designed accordingly. I found the best place for the servo right on top of the front axle. As for the rear wheels, they are powered by 2 motors. Initially I attempted to use one motor with the gear connected to a fixed shaft for both wheels, but this setup didn't work well. Then I switched to using geared N20 motors, and 2 of them fit perfectly. This arrangement eliminates the need for a differential gear, as it can be achieved electronically. Each motor gets its own H-bridge to control them individually. Then add the PWM controller board, and the space is full at this level. The next level of the design accommodates the battery, which occupies all the available space. On one side there's a small button that can be pressed against the on-off switch on the battery pack. On the other side there's a cutout for the charging port. The top level of the design features a mock-up of the driver cabin, complete with a futuristic-looking camera holder on top. The flatbed section of the design houses the Jetson Nano board, with the possibility of adapting other boards in the future if necessary. In the end, I was satisfied with the design, even though it turned out to resemble more a truck than a regular car. However, I decided to stick with the name JetCar instead of renaming it to Jet Truck. Next, I had to consider creating a street map. Utilizing the 3D printer, I designed a tool that could hold pencils with appropriate spacing for lanes and lines. This tool could be used to mark straight lanes or curved lanes. To create the actual street map, I purchased a large paper roll from the hardware store. I used some of it to make templates, which I then cut out. When these templates were placed on the desired surface, I first sprayed the area with black paint to represent the future street. Then I flipped over the folded parts. I could spray the border lines with white paint and the center lines with the yellow paint. I also created templates specifically for intersections. It was a lot of work, and some hours and some spray bottles later, I finally had a street map I could work with. That's the end for this video. Thank you for watching. I hope you enjoyed it and got you interested in watching the next one. And feel free to click the like button. Goodbye.